We're going to be discussing experiments in this video, and this is another way, in addition to observational studies and some other ways of collecting data. We've got, well, sample survey would be the other one I suppose we've talked about. And what we're going to do right now is talk about these experiments here that you might be a little more familiar with, maybe not. And let's read on here as I'm going to underline and highlight a few things for you. So, an experiment is a process of trial and error that's used to test a hypothesis. We force a cause to observe an effect, although this doesn't necessarily mean that there's a valid cause and effect relationship. So we got to be careful about this one. And in this case, we are the ones that are forcing this cause and effect. So that's kind of a difference between an experiment and an observational study. We're not just observing things, we are affecting some of the trials or some of the experiments here. A control population is compared to a test group. So the control population is no treatment. So that's right here, control population, and you're comparing that to somebody that, or a group of people that gets the treatment or whatever that is. Okay, so we're going to see if there's a significant difference between them. So you could do this if you were to test a medical drug. Let's say you believe you found the cure for cancer, and of course you'd want to make sure that that was actually the case. So you might be able to do some kind of an experiment here. Key principles of experiment design control. You should compare that with two or more treatments. And then also, we've got randomization here. What does that mean? Well, the experimental unit should be randomly divided into groups. So you don't want to bias your results. So in other words, if you're looking at a particular, I don't know, medical drug that's designed to help people with heart disease and lower their risk of heart disease, you wouldn't want to divide people who are athletes with people that maybe are not, because that's going to affect the results. You'd want to pick a few athletes, you'd want to pick a few people who aren't or aren't working out, and you'd want to include those in one group that got the treatment, and then also a similar type of group for those that didn't get the treatment. And then you could make a better conclusion about the effectiveness of your miracle heart disease lowering drug. Replication is also another thing. So you should be able to replicate another experiment that somebody else has done. Or if you do it yourself, you should be able to replicate that experiment time and time again. The results should be very, very similar between those. If they're not, then you might have just gotten something at random that seemed to either work out or not. And you'd want to be able to make sure that that was repeatable, that experiment would be repeatedly able to work. We also need to control for bias. So there's a way that we can do that, but let's discuss what bias is to begin with here. So really, bias is going to be the difference between the measured outcome, so what you've figured out in your experiment, and the true outcome. So there's some bias involved when those two things are different, when what you measured actually isn't the truth. So that happens sometimes, and our goal is to reduce bias as much as possible. What about here with blinding? What is that about? Well, blinding refers to the fact that the subjects don't know what group they are in. So that would be control versus getting the treatment there. So in that case, you would be in the test group. So I think we use the word test group, or some people use the word treatment here. So we could say control versus test groups. You don't know whether you're getting the thing or not. And actually, we can go down to placebo right now, because a placebo is a treatment that has no effect. So you would usually use this on the control group. So you give them a pill, but it's like a sugar pill. It doesn't really do anything. Unless you're studying diabetes, then that would be an issue. It's a treatment, though, that has no effect. So you would use this, and see here, usually with the control group, or usually given to, let's say that, okay? So usually given to the control group. So if you have all the people that you're studying, and you give every single one of them a pill, you want to make sure that some of them get the treatment and some of them don't, but you don't want them to not get a physical pill because they might go, oh, well, I'm not getting the treatment, and so things are going to get worse for me. And there is actually an effect called the placebo effect. So if you believe you're getting a treatment, sometimes that can raise your mood, and you can say, oh, I'm getting a treatment, and that positive style of thinking can actually have an effect on whether you get the results you want or not. So let's go back to blinding here. Now, double blinding, so we said blinding is where subjects don't know what group they are in, but the researcher does. Double blinding is where both the subjects and the researchers don't know who is in which group. So you would have somebody prepare things for you, and then as a researcher, you would just give everyone a particular treatment, and some of those treatments are placebos, so they wouldn't actually be getting a treatment. And then other ones do have the treatment in the in whatever form you would like. And so what's going to happen here is that there's no bias between the subjects and the researchers. Sometimes researchers know, if it's not double blinded, if it's just blinded, the researcher would know who's getting the treatment and who's not. And there can be subtle hints or ways that the researcher handles each one of those. So in a double blinding, the subject and the researchers don't know who's in each group, and that actually is a really good thing. So there's no bias, hopefully, within either the subject members of each group and then also the researchers themselves. So why would you choose to design an experiment to collect data? Well, you'd want to do that to support or refute a hypothesis. And this gives you actually quite a bit of control here as the researcher when you're doing these types of things. So you can actually design an experiment to figure out if you were right or wrong, or if somebody else maybe is, and we can build our scientific knowledge on that. Why would you not want to? Why would you not want to do that? Well, uh, it's expensive, or they can be expensive. There's a lot that can go into these different things. There's ethical considerations to take into account. You have to get the people in each group all set up, and there's lots of different things that you can do. Also, there can be, we just said, some ethical concerns. Those can definitely be some issues with